To math with Miss Swartz. Today we are going to be looking at composite figures. Today is not going to be much different than what we've been doing because all we're doing is taking the different types of figures we've used so far, such as cylinders, prisms, cones, spheres, and we're going to be using these formulas to figure out, okay, what if we had a cylinder and a sphere or a hemisphere together? What if we had a cylinder and a cone together? Or what if we had a rectangular prism and a cone together? Okay, so we don't really have a lot of new information here, but we do have to use our formulas and to write out our formulas, and we have to show all our work. And we have to understand how some of these figures work together. So this is kind of our last video notes day. So that's exciting. You have one more video that you might have to watch the review, but this is your last day where you're taking notes. You do need to write down all of these examples. Really all we have today on the notes is examples, so make sure you have all of these down. I don't have them boxed off for you today, but you need to write them down. So let's get started. So first one here, we have a picture of a silo. Hopefully you've seen a silo before. And what we have is a hemisphere at the top of the silo. That's half of a sphere, so we're going to have to keep that in mind. And the radius of that hemisphere is 12 feet. We want to know the volume of the whole silo. So we need to figure out, okay, what are the two figures that I'm looking at? Well, first of all, we have our hemisphere. Okay, so if I think about a sphere, okay, we did this formula. And really what we're going to ultimately be doing with this formula is dividing it by 2 because it's a half of a sphere. Then we have the other piece here, 3D dimension there would be a cylinder. So pi r squared h. So these are just a couple that we've used in the past, and we're going to use those same ideas to help us figure out the volume of the entire silo. Okay, so first, the hemisphere. Well, it tells us the radius is 12, so that means the height right here is going to be 12 because it's halfway across. If it's not, okay, a full sphere, the radius is going to be from here to here, but also from here to here. So that's 12. So if this is 12, what does that leave this to be? Okay, well, the whole thing's 52, so that would be 40. So we have 4 times 3.14 times the radius, which is 12, over 3, and then we're going to eventually divide all of that by 2. Okay, so 12 cubed, and here's where some of you kind of got mixed up the other day. 12 cubed is 12 times 12 times 12. That's 1,728. We're going to be multiplying that by 3.14 times 4. And then dividing it by 3, and then dividing all of that by 2. So I'm going to multiply that by 4 times 3.14 divided by 3, which gives me 7,234.56, and then divide by 2. So the volume of the hemisphere is 3,617.28. Okay, now the cylinder would be pi r squared h, so the r is still going to be 12, and the h here is going to be 40, not 52, because that's the whole height. So 12 squared is 144, times 3.14 times 40 gives me 18,086.4. So now if I want to find the volume of the entire silo, it's going to be 3,617.28 plus 18,086.4, which gives me 21,703.68 feet cubed. All right, so let's go on to some more examples here. Number 3. Okay, so what we have to figure out the shapes that we have first. That's always my first step. So I have a hemisphere and a hemisphere. Well, if I take a hemisphere and put them together, that gives me a sphere. So I'm just going to do the spheres formula. Then I have a cylinder in the middle of those two spheres. So pi r squared h. Okay, so now I plug in what I know. 4 times 3.14. I'm going to move this out of the way. Times my radius is 2 cubed over 3. So 2 cubed is 8. If I multiply that all out, I've already done it, so I got 33.493 repeating, and we can kind of round towards the end. So 3.14, my radius is still 2, okay, on the cylinder, but now I have to be careful with the height. So you can think about it like this. If this whole thing is 8, so as I was saying, the height, okay, if we could think about, okay, if the radius is 2, that means this piece right here is also 2, and this radius here is also 2. So what's left in the height of the cylinder? That would be 4. So if we multiply that all out, 2 squared, oops, almost forgot that, is 4. So 4 times 4 times 3.14 gives us 50.24. So now we have to take these two and add them together. So 33.493 plus 50.24, and we get an answer of 83.73 inches cubed. Awesome. All right, so I'm going to do one more with you, and then I have a couple you're going to try on your own. So this one has a cone and a cylinder, so I'm going to write the cone formula to start. So pi r squared h divided by 3, and the cylinder formula, pi r squared h. So fill in what I know, 3.14. The radius here is 3. The height of the cone is 5, and divide that by 3. So I have 3.14 times 45, because 3 squared is 9 times 5 is 45, divided by 3. And that would give me, if I type that in, 47.1. Okay, so 3.14 times the radius of 3 again. It's the same for the cylinder. And the height of the cylinder is 9. So I have 3.14 times 81. 3 squared is 9 times 9. And that gives me 254.34. So now I again need to add those two together. So I have 47.1 plus 254.34, and I get an answer of 301.44 meters cubed. All right. So you're going to try these two on your own. Make sure that you are careful, write out each formula, show your work so that we can see where maybe you went wrong. Make sure you have a cone and a cylinder here and a cone and a cylinder there. That's all we have for you. So after you are done with these, come show your notes and get your worksheet. Last one. Have a great day.